Well, hi and good evening, and thank you so much for joining me here in my shop. It's June 10th, and here comes a tub of radio here. So this is a somewhat famous Wonderbar car radio. And my job with this is to just see that it does work. It apparently was in someone else's hands some time ago, some repair person's hands. They did some stuff to it and got it working on their bench. But when it eventually got back in the car, it wouldn't work. So it's not at all convenient to return it to the first guy, just circumstances. And so it's come to me because I'm a little more local. So let's see what we've got. So we've got the speaker here, obviously, and the power supply with a vibrator, and the OZ4 tube. Some information that's come with it, including the alignment instructions. We should, for some reason, get to that point. And the schematic there. And here's the radio. It's actually quite large for a car radio. Okay, and take them out. Ooh, not as heavy as I expected. I thought that would be a lot heavier. But I guess, it's an automobile technology to try to make it as light as you can get away with. So the interesting thing about this radio is it has automatic tuning. You push this bar called the Wonderbar, and then the radio will automatically tune. I thought it was to the preset buttons, but that doesn't make sense, does it? Because having it automatically go to a preset button, well, you just push the button. Why would you want that? So the problem with this is it just didn't seem to work. And what I'm going to do here tonight is set it up in my shop and see if I can make it work here. And if not, then I'm not sure what I'll do tonight. But if it doesn't work, well, the first thing I would suspect is the vibrator. Always. This looks burnt here. Huh. So that looks kind of bad. So this is conveying the power from the radio. Let's put it this way. This is the positive terminal. Looks a little burned also. Positive terminal. The frame is the negative terminal bolted into the car. And the power supply is sitting over with the speaker. I have no idea why they designed it this way, but they did. And so the on-off switch is here. So somehow power has to go through here to get there to have an on-off switch. So that's why the power comes in here and gets over to the power supply. The purpose of the power supply is to raise the voltage. And the vibrator is a very important component of that. But this burned wire right away, I'm suspicious about this. It looks bad. Let's take a closer look at that and see what what we see. Other cameras right here. Okay, so we're going to just try it with the autofocus, but sometimes the autofocus is a little annoying with this camera. So here we are. Well, I mean, just on the face of it, the wire is shorted out here. And would you believe it? I used to be, years ago when I was much younger, working for the power company in Toronto. I worked in the engineering department, and one of my jobs was cable failure analysis. Can you believe it? So looking at this exact kind of stuff, only look at my fingers, it's a little tiny wire. I was doing this with huge power cables. So that looks like a hole right through the inside insulation underneath the copper, the braided copper shield. A hole right through, and it looks a little green in there, maybe. It's a little hard to see, but I don't actually see any copper, and I'll tell you where I'm talking about here is right in this hole here. But, you know, think about how did you end up with this hole? The ends are frayed and it looks like clean copper all the way up to here too. So if you had a short circuit on a car battery driving it, you get a big pile of current here, and you would rapidly melt back these lighter wires, and you would also melt back the conductor. The insulation appears to have been able to sustain the heat. It's still sitting here. So it would have burned back the conductor a distance and then stop, because the whole thing just become too difficult to keep the arc going between here and there. This all happened in a flash, like that. I'm willing to bet the conductor is severed inside here. And I'm just gonna flex it a bit and feel it. So of course the cable's really weakened because half the shield is gone. So I mean, it definitely feels weak in here, but not weak enough to say the conductor shot inside there. So this would have made some noise, and this definitely would have generated some smoke, and potentially pop a fuse, either, you know, a car fuse. I mean, that's the whole idea. It should pop a car fuse. But this one looks more like it did what would be called burned clear. And like I say, it would have happened in pretty much a flash. Is this the problem with this radio? Well, you know, even though I think the conductor's continuous, how do we really know? So this is a two wires, 3 terminals. So you can guess one of those is for the shield, the other 2 are for the center conductors. And they disappear into the radio. So from outside here, it's a little bit tough to prove them out. We'd have to take this off and prove out the cable that way. In any case, this is a serious problem in itself. We can't leave it like this. And we can't put power to this with this situation. So I guess really the next step is to get at the other end of this wire in here somewhere. It looks like this piece. Just take off these. Oh, they're already loose. Take these screws off. Take this knobs off, and presto, we'll be able to get at the other end of this wire. Then we can do a continuity test and then decide what to do about it. Sounds good. Break time. Already. Okay, let's see if we can get the cover off here. I've got the oops, almost all the screws out. There we go. All along the side here. Okay, I've got the knobs off. There's the screw on the knob. That off. Okay, should be able to pop this up. something to do with this. Something is holding on here. This is moving. These funny little pieces here. And similar up through here, all these. Don't understand why this just doesn't pop right off. It's the kind of thing where just about the time you realize why it's not popping off is about the time you realize you've broken something. They go hand in hand. Very frustrating. I might have to resort to reading the instructions. Hey, speaking of which. Parts list. Plastic light chassis view, bottom and top. Does it say anywhere about taking it apart? I don't think so. I don't think so. But it shows there an exploded picture. So this is this is the cover off. I just wonder, you know, like there's wires down the side here. They're just like this stuff here. It's just pinching on here, and I'm just not willing to pull hard enough. Didn't really help out. It certainly is useful down the road. So these certainly appear to be attached here to this, and these things too. This wire comes out and goes back in. What's that all about? So you can take off a metal cover here and leave everything behind. This can't come along. Is this plugged in here? Is this plugged in? Is it plugged in? Okay, is there a hint on that? What is the wire on the side? There it is there. Wire on the side. Wire on the side. think there's anything here that's going to help with that. Well, there's an interesting slot here. Why would they leave a slot there? Would it be for somebody to go like this? Hey, how do you like that? Oh my gosh. What do we got here? Okay, all right. Very good. That does not look like the correct light bulb, but okay, that was exciting. Now, was that holding it in? Maybe it was. You know what? It could have been. This could be, yeah. I'll bet you this comes off now. Presto. Excellent. Nothing got injured. That's the main thing. Except my ego got a little bit wounded there. Okay. Fantastic. Just take a look at this. Yeah, this capacitor really should have been changed. This one too. I see one here that does look like this is a capacitor somebody's added. A replacement here. In the power supply, there's some very, very serious capacitors. So, looks to be in good shape though. I don't. Okay, here's the wires. This is what we're after. Let's take a look here. Look at my world-renowned Allen meter. Thank you once again, Allen. Okay, and what we're going to do is I'm just going to put this, I'm going to put it right on continuity here. Don't really know for sure which is which. You think it could? It could probably. Good presumption is it's that one. That should be the center conductor of the damaged wire. Damaged wire coming around. This is the damaged wire. Here we go. So not open circuit. And the other wire just for fun. Ooh. It's got to be right there. Ooh. Huh, isn't that something? Oh, I must have hit something else. Is there a light coming on? Is there a light on there? Maybe it's this. Maybe I'm not doing a good contact up in here. Let's try again. Some chance this one. Well, I didn't expect that. I would have thought that would be ground and this would be you know, the two center wires. But it looks like this one must be ground. So that's ground. That's one white. That's the other white. So the wire's okay. You know, you have to ask yourself, well, what happened here? So one possibility is it got speared. Got speared by something, crushed or cut into by something, causing the outside braid to be pushed right in, right through the insulation and into the conductor. Other possibility is, and I think a more likely possibility, is something's going on in this area. It's darkened all the way there. And after something goes on for a while, then there's a short circuit. I'll write that in the report. Yeah, it could have been pinched or something. It doesn't, so, you know, when I curl it, it doesn't like have a particularly sharp bend right here because it's been so weakened. Because it hasn't been so weakened, the conductor is still there. You think if something had like something sharp clamped down on it, squeezed on it, you know, slammed the car door on it. What are you gonna do about it? Okay, so these are pretty frayed up in here too. What am I gonna do about that? So you could re-insulate it somehow, but how would you do that? How would you do that? You cut the braid, kind of pull it back. See what the conductor's up to. Put some kind of tape on it. And that's, or replace the wire. But if you replace the wire, you've got to break into here. You cut this out and remake it, which that's called shortening up. That was a term from the power company I worked in. Just shorten it up. The copper here's got so much black on it. And the reason I'm saying this, I'm thinking about how you're going to solder to that. You know, to cut this whole section out. I got a cat just whining outside my door. Let's just check it out here for a moment. Is there somebody out there? Who's out there? Oh. Hello, Bert. I'm sure it won't be long before Bert. Oh, Bert's going to jump and get into big trouble here. Okay, that's a little safer for you. Bert likes jumping up on my bench. And, okay, there we go. Oh yeah, right. So my choices were we'll cut this right through. Work our way back a little bit. I can even splice a jumper wire from here over to there. It's not even 100% necessary, because it's just as long as one of these is continuous, we'll be in good shape. But let's try to fix this. But I could even jumper it, you know, wrap some wire here, bring it over, wrap it here, and solder. Cut it open, we get a better chance to look at what's going on there. But I did say I was a cable fault analyst, right? That's a weird title. You got a cable? It's got a fault? I'm your man. Well, only certain kinds of cable. Let's take a look under this again. The cat is playing hockey behind me. So now if you look at right where the conductor is, I think what you're seeing there is the charring of the insulation, where it's white. But not an awful lot of it got destroyed. Yeah, well, what I'd be asking myself is, am I seeing deterioration that happened at the time of the failure? I'm just having fun with this, by the way. Am I seeing deterioration that happened at the time of the failure, or is that previous? The thing was deteriorated and then it shorted. Why are you making such a big deal out of it? Because it's fun. It's just fun. It's fun to think about these things. You know, we're blessed with these fantastic imaginations that you know, we have control over. I think that's one of the things that's right through it. One of the things that sets us apart from all the rest of the animals is we have control over our imagination. We can do all kinds of things with it. And I think most other animals are controlled by their imagination. Oh, it's really kind of charred, eh? Like, that means that didn't happen quite so fast. Oh, green. Green right there. So that's copper corrosion. How would this get corroded? just in one spot like this. That would be kind of weird. Sometimes when there's a failure like this, the temperature can get so high that you can have chemical reactions that you wouldn't normally expect. So maybe that happened. Maybe it got. I doubt that. That sounds like a baloney story, doesn't it? This might give us some idea of the condition of the rest of the wire too. So there's a lot of carbon kind of blowing up into it here. So there's a good boom when it went, that's for sure. And blue stuff. I don't know, maybe I could put my microscope on that. Yeah, why don't we do that? And make a big deal out of a small deal. Sounds like a good idea. Okay, this is looking under a microscope here, and you can see the conductors that I cut. Oh no. That's my cat walking on my keyboard there. So you can see where I cut through some conductors. That's not too interesting. That's where you need to look at the other end. That's the shield. Oh. Cat is going after my microphones here. I'm going to have to stop for a moment. It's about to get pretty crazy. There he goes. Okay, hold on there, cat. Oh my gosh. Hey. Uh-oh. Before something really bad happens, I gotta get him. And just like magic, 24 hours has gone by. It's actually the next day now, the evening of the next day. So we're going to continue looking at the fault here. We'll call it a fault. So here's the microscope view. Obviously we're looking at the braid on the outside of the cable here. I can adjust the focus up and down a bit. Okay, let's move along towards the end. This way. Oops. I'm pretty quiet while we look at this. Maybe the magnification is a little too high. Let me reduce it here. Just as I'm getting everything set just right, look who shows up. Okay, Bert. Whatever my hands are doing are interesting to you. Let's just do this. Because it's on a lower magnification, I can manually do this much easier. Or don't step on the wire. What happened here? There we are. Okay, so we can see the cat walking over my keyboard. Here we go. See the outer braid. You can see the inner insulation quite clearly there. What I'm looking for is some evidence that there was damage to this before it failed. Let's see if we can tip it up a bit here. not going to be able to make anything out of that. So, you know, no doubt this thing burns for some period of time, a fraction of a second perhaps, like half a second or a quarter of a second, long enough to burn this stuff off, and maybe damage the insulation the way we see it, with that strange kind of very yellow color that it is now. Of course, at the high temperature, you know, different chemical reactions take place. So, and plus there's copper, vaporized copper, so that could even be green from vaporized copper. You know, that's a good possibility. The other thing is, you know, if I could cut this open, and I won't. I used to do this with great big cables. Look at my fingernail. It's just a little tiny wire. We cut it open, excuse me, and look for evidence of water have been inside the cable. Now, I mean, this is a radio from a car, so water inside the radio. Underground power cable is a different story, of course. Water gets in. Okay, I don't think we're going to figure much out here at all. In case you're wondering what all that noise is, it's him. Okay, so let's get around to fixing it. Whoops. What happened here? Let me just click this. Okay. Yeah, you're going to help. You're going to help by chewing the wire? That's not going to help. What is interesting to you? This carabiner? You like this? Don't lick it. Get your own carabiner. That's what I would say. Okay, so we're going to clean this up, and I'm going to start working on that connection. And Bert, Destructo Cat. Okay, I've banished Bert from the shop here so I can get something done. I think the first thing is, let's just see how bad this really is. I think it's just a bunch of, like, basically smoke darkening it. Not much more than that. I think an interesting question would be, did the fuse blow in the car? And is the owner aware of whether the fuse blew or not? Because this could have happened, and then the fuse is blowing, and even though the wire is continuous inside, was continuous, the blown fuse would preclude the radio from working. So the person checking this out might not realize this happened, might not realize the fuse is blown, just has a dead radio. Now, I don't know what an old car this came from. Would it have a fuse for the radio? You know, it might. It might have a fuse from the radio. This has also just got a layer of soot on it. You can imagine it's burning off a little bit of this plastic and doing it in a sudden way. It's very likely there's going to be unburned products coming out of it. Carbon, in other words. I'm cleaning it up to get a good look at it, and I think it's worth doing anyway. I guess the dirt will probably go all the way up to here. In the case of underground power cables, this outside part, these are big power cables under the streets of a city. This would be common around the world, but a little bit old. technology. There's newer types of cables, but the older ones had a metal outside on them. It was called a sheath, and it was made of lead, but you could really think of it as a lead pipe. And when they build the cable, they build the inside, then they have a way of squeezing the lead onto it and forming this continuous sheath or lead pipe, basically. I was floored when I first started working in this power company, learning this stuff, because I had no idea. Even though I'd gone to college a bit and studied a bit of electricity, I had no idea. And then I was shocked to find out that lead pipe, and inside the lead pipe is the conductor, of course, but what's the insulation? Paper. Paper. I couldn't believe it. Paper insulation in high voltage cables under the streets. High voltage being 8,000 volts. 8,000 volts phase to ground. I can't remember now. 13.8 and 8,000. So I think it's so the conductor is 8,000 volts on it through the insulation to this lead sheath. It's a little more complicated than that, but with paper insulating it, wraps of paper, like picture paper, about this kind of width, just regular brown paper. Well, it's not brown, but paper that has been washed and cleaned, so it's got no ions in it, nothing conductive left in it. In the process of making paper, don't they use acid and all kinds of stuff? So it's tricky to clean the paper enough that you can use it in a power cable. But this is what was figured out pretty early on. Assumably this is carrying a bit of power. It's not the biggest conductor. I don't know, should I go back a little bit further? Oh, I could just do this. Oh, heavens, just do this. Oh, hey, that's the way. Yeah. Now, why am I going to bother cleaning that? I don't know. I carry on with my story. What was my story about? Power cables and conductors insulated with paper. But it's not just ordinary paper. It's paper that's been impregnated with oil. Impregnated paper. So what in the heck are they talking about? So paper's made of fibers. Fibers are little tubes. And there's a way to get oil inside those tubes. Tiny little fiber tubes. I went to the cable factory in Toronto to see these cables being made. These cables are this big around. Inside are 3 conductors, 3 big copper conductors, stranded copper conductors, but big strands, and paper wrapped around them. And somehow they take big wheels of paper and spin it around the cable. But this is huge. This is the size. This is gigantic. What's going on? I went to the factory to see this. I was just blown away. And the way they get the oil into the paper is they wrap the conductors. So the conductors are insulated with dry paper. And they wrap it on a great big reel. You've seen those big reels on trucks? One of those big reels, and they wrap it all around the reel. Do this in the factory. Then they take it over to where they have a huge tank. Now you can drop this reel in. The reel goes in. Maybe they do 2 or 3 at a time. I don't know. In goes the reel. And then on goes the lid, and then they bolt it down so it's vacuum tight. It's a great big thing. So picture a huge reel of cable like that. No lead sheath, just the paper. In it goes. They draw a huge vacuum on it, and and I guess this dries it a bit too. I'm not sure about that, but it probably does draw off the moisture and everything. To get the vacuum down low enough, they then allow oil in, special oil, obviously carefully formulated oil, goes in, and because there's no air inside the fibers, the oil will penetrate and impregnate the fibers. Yeah, and that's what's inside these cables. And this was figured out in, I don't know, very early 1900s. That this is a way you could successfully make a cable and stick it underground. Because before that, the attempts were pretty sad. So, nevertheless, once you get a lot of this cable under the ground, and you're operating it, some of it is 30, 40, 50 years old, things are going to happen. Cables are going to fail. So, in my situation, where I was supposed to examine these blown pieces of cable and figure out why did that happen? without any particular training. I mean, there's no real training for that. There was a couple of weeks in the city of Toronto. So, okay, so let me just keep those meshed like that. That would be excellent. Okay, now we got to stop and think a little bit here. Stop talking. Get this far enough away from here. When I solder this won't shrink prematurely. Premature shrinkage, we don't want that. I've picked a pretty tight sleeve here that I have a hard time. Wow, I can't get it away from here. Yeah, so my job, going back to my job years ago, was when one of these cables failed, I'd become informed about it, and off I would go, get in a truck and drive out to the location. Often the crews were there already working, and sometimes they'd already pulled cable out of the ground, that defective cable. You know, they pull it out between manholes. Everything is manhole to manhole. So you're not replacing a couple feet of cable. Even though the fault is like this, it's just a little tiny piece. You can't do what I'm doing normally. You have to replace a piece all the way to the next manhole. Could be 100 meters of cable. We're talking thousands and thousands of dollars. That's why it was important to investigate these things and try to come up with ways to reduce them. Yeah, so the crews would be doing the heavy work, and I'd be the geek that showed up from the office, you know, from the engineering department. Who are those assholes from downtown? That was me. And I see the whole length of cable as they pulled it out on the ground, and then they would, you know, out would come this big, like this thing, only this big, in this cable the size of your arm, and then they would cut that for me with maybe a meter length of cable with the big fault right in the middle of it. And I'd throw it in my truck, and ooh, look what I got. Got no idea what I got. And bring it back to the head office and sit in a room not much different than this one here. It's actually a storeroom in the basement with a kind of knife called a hack knife and a hammer. And I chop these things up. I chop them up nice and careful. This isn't going to work. As soon as I heat this up, this is going to shrink. So we'll just have to do some other kind of insulating on it. Chop it up and take a look at what's going on, just like you saw me do with this cable, only we're talking big size stuff. Here, look at my soldering iron. So it's kind of exciting, though. You know, each time I'm getting called to go out to a site to see where there's a fault. I'm going to do a little investigation. I'm going to look into the history of the situation. I was keeping all kinds of cool records, and I could go on and on about this. you know, we're in the evening here. I'm usually working in the morning. In the evening, I'm able to babble a little more. Now, who's taking my solder? Who took the solder? Here it is. Coming apart. Did I not sand it at all? I was not happy about getting soldered. Yeah, there it goes. Okay, turned out to be it did not work out all that well. Well, it's a good joint, but the shrink sleeve is, yeah, that's hopeless. So what I'll do is, many of the failures in an electric system can be in the splices that are made between these big cables, and if you think doing something like this is involved, it's not. Splicing these great big cables together is very involved, and it does require a lot of skill to do it. It's an all-day process to make one splice, one three-phase cable, and these conductors would be they'd be more like that. Each conductor is about that size there. 3 of these guys this way, and 3 of them come in this way, and you've got to get them together, and you got to sleeve them, and it's really quite a well, it's a trade, and it takes a long time to build up enough experience. The problem is, let's suppose you're making an electric system and you're putting a splice on every cable in every manhole. That's how it works. Every cable in every manhole gets a splice. And you work away on it for 10 years. And by then your company has made, I don't know, 20,000 splices. Who knows? Big, big number. And one of them blows. And you look in it and you go, oh no. Did we make them all this way? That's the scary thing about working in a system like a hydro system, because the chickens don't come home to roost for a long time, and when they do, it can be kind of ugly. Okay. Well, I was kind of babbling there. Don't really know what I said. Now I'm going to have to bridge this with a wire and try to solder. I mean, there's no way I'm going to get this jointed this way. So let me get that set up here. Okay, I can keep talking. Manhole fires. So another thing that's really scary to a power company in a big city, this would be any big city in North America, around the world, manhole fire. If you get a manhole fire, everything in the manhole can end up on fire. Well, you could have all kinds of cables running through there doing all kinds of things. In some cases, maybe not even power cables, and maybe other communications cables. Who knows? Depends what you're going, what the rules are in your particular city. Yeah, well, how can you get a manhole on fire? It's hard to imagine how much energy is released when the power cable shorts, at least in the Toronto hydro system. Here. And I'm sure there's nothing unusual about the Toronto Hydro underground system. We're talking about downtown, big tall buildings, lots of very dense load there. So there's a system in the downtown of Toronto. It's called a network system. You have a network of low voltage cables going up and down the streets, all connected together like you see my fingers going. So you can picture a network. They have buildings hooked up to it taking power out. They have transformer vaults dotted around it being fed with high voltage and then converting that to the low voltage to go onto the network. This is a very, very tricky way to distribute power. Normally power is distributed like on the extension cord. It just radiates out. It just like comes out of the station and then maybe heads this way, that way. But there's none of this happening. There's no networking in most systems. It's just called a radial system. It's a network system. So the deal is, you set something like that up, oh my god, you have all these vaults with these big transformers, 500 kVA transformers, big powerful transformers, all energized from different high voltage feeders. The whole thing's set up so the load is all balanced, and one of the cables fails. Let's say on the secondary side, the low voltage cables, 120, 208 volt cable fails. The amount of power that's available to go into that fault, and I'm not saying all this power would show up, but in certain circumstances you would get something like what I'm going to describe. The amount of power that can be present in the fault, which is going to last 2-3 cycles maybe, well, is equivalent to 1/3 of the entire load of the city. Wow. Like I used to say, you can make a lot of toast really fast with that much power. That's how you set a whole manhole on fire. You literally torch it within fractions of a second. So of course steps are taken to reduce this possibility in an electric system. They space the cables apart, wrap the cables with protective materials, and try to keep things neat and tidy, which is really, manholes are filthy, dirty places. Just filthy, dirty places. Full of water. Everything else that can come off a city sidewalk. Get into the manhole system. Yeah, not a happy thought. Okay, let's pull up some wire here. I'm not quite sure how I'm going to do this. Lots of wire. I was in many of those manholes over the years. I remember the day it dawned on me. I was going into manholes at a certain rate, roughly, probably maybe 10 per week, doing investigations, examinations, taking tests. I got lots to say here, which I won't say. And then one day I sat down and said, gee, at that rate, how long will it take me to see a substantial portion of the system? The system had 10,000 manholes in it at that time. 10,000 manholes. So the realization was, I'm never, ever going to see even 10% of what this system is that I'm supposedly supposed to know something about. I just remember being kind of freaked out by realizing the enormity of it, of the whole thing. Yeah, good times back then. Good company to work for. I think this is a good idea, what I'm doing here. We will see. That's enough. It's almost 9:30 in the evening. Okay, let's try soldering that with my solder. There it is. So there were occasions where people witnessed a manhole cable failure. And then they'd be described in the news. So I pay a lot of attention to that because personally, I hope to never witness one. I don't think that's soldering down to the braid here. Really got to heat it up. Wow, it's not working. Come in, not working. I'm gonna melt the cable through the wire inside. Ooh, that worked a little there. Good. Wow, took a lot. And from the descriptions that people would describe, ooh, what? Stop. Yeah, something like that. People would describe flames going 100 feet high out of the mantle, the lid flying off, loud explosions. Wow. And there was some two cable jointers. We called them jointers, not splicers, who were in a manhole when they accidentally triggered a failure, short circuit, which of a sort that you do not want to do that. And one of them would never went in a manhole again. They didn't get hurt. They just had the shit scared out of them. That's the only way to describe it. And the one guy who just could not go in a manhole again after that. So, yeah, and I knew this kind of stuff going into manholes. Well, you know what? That's probably good enough. As long as some care is taken, I suppose they could put, tape right over top of the whole thing. But it might be better to leave it in the open, certainly right now. So we can witness if it fails. Okay, a little bit of a break time, and then we're going to try to energize this thing and see if it works. This is the positive lead that goes into the radio from the car. You can see how tarnished it was, or it is here. I just have a little bit of sandpaper. We're just going to scrape off the tarnish. And of course that reveals the metallic shine that we're so used to seeing. You ever thought about what that shine is? I believe that's the electron cloud, the mobile electrons, sometimes called free electrons, but I don't think they're really free. And they're responsible for that metallic sheen, I think is the word. Of course, you want the electron cloud of the two pieces of metal that you're going to try to connect electrically to be in contact. And they can't be in contact if you've got too much of a patina on there. Certain kinds of patina, anyway. Okay, now we need to make a connection to my power supply, which is a little bit, maybe it's this guy here. So I got to figure some stuff out here. Okay, I think I'm ready to try it out. So here's the story. So radio goes to somebody like me. That person works on it, and it's working in their shop on their bench. Radio goes back to the owner, puts it in the car, it doesn't work. Gives it to me in the hopes that I can fix it. He didn't give it to the other guy. The other guy's just too far away. So he discovered me, so I'm just more convenient. So here it is. So what I discovered right away is this blown wire. Kind of lucky in a way to spot that. And the story I would have is at the time this went into the car, this cable gave out for some reason. That didn't ruin the cable. Like it didn't blow the conductor open inside, but it popped the fuse. That's my guess. And with the fuse popped, and the fellow kind of frustrated over, oh my gosh, look what's happened here. He may not have thought about checking the fuse. I don't know. Perhaps he did. I could be telling the wrong story, but this is the story I got. Okay, now here's what I've got hooked up. So we could start with the antenna. So this is going to an outdoor antenna, pretty good antenna, Should make a radio like this work really well. I have the power connected over here. It's good for me to review all this, by the way. White wire is carrying the negative back to here, and the negative is brought back over here by the shield that I've repaired, and the good shield here. So I don't think I need another negative wire coming over. Speakers connected. Wires appear to be polarized. There could be a good reason for that. The speaker frame is bolted right into the car frame, so it's right on the negative terminal, so to speak, of the battery. My power supply, the lowest output voltage is 6.3 volts. When you set it to the bottom, it's still 6.3 volts. It'll go up to a little, I think it'll go maybe 15 at the most, and it'll produce 30 amps, which is more than enough, I would think, to operate this radio. Sometimes there's some difficulties with the startup. It draws too much current from my power supply. My power supply complains about stuff like that. It has current limiting in it, and it also has a beeper that'll go off and it'll beep. It's very annoying, I have to admit. So that's the story. Now I should drop the knobs back on, provided I can find them. Where'd you go? Here. So the shafts are circular. I'm going to have to tighten the screw down a bit. Okay, practice. That's obviously on and off, so that's off. And this is tuning without a doubt. I doubt there's any problem with having it tipped up this way. A little hard to see the front dial though, isn't it? So why don't we do this? Okay, let's give it some gas. So with the switch off, turn on the power supply. I'll set the voltage to 12. Okay, I'm going to be leaning out, leaning in front of the camera a bit here. Let's see if we can just move a few things. Maybe not. Maybe not. Okay, here we go. Power supply has a cooling fan, which you can probably hear now. Has a voltmeter and ammeter. You can see the ammeter. The ammeter is 0 because it's not powering anything right now. The voltmeter is reading about 6 volts. So we're going to set it up. Volts. A little over 12 volts. I think 13.8 is the nominal voltage in a car. Okay, so if I were to turn this on, it would come on. The light is hanging around over here, but it's not grounded, so the light will not come on. What would we expect? What possibility is the load is too much for my supply and it shuts off the output and starts alarming? That's one possibility. Another possibility is wait 15-20 seconds and the radio comes on. That's a really good possibility. Only one way to find out. I always find I delay these moments. There we go. So you see the current flow jump up a little bit on the ammeter. Go up come down a bit. That's normal. It's a good sign. So I'm gonna listen to the vibrator here. See if it's doing its thing. I think the vibrator is dead. That's my impression. I don't hear anything at all. And what I shouldn't say that. What I do hear, I hear exactly the same thing if I listen anymore. And it doesn't sound like a vibrator. So my guess is it's not going. What we saw was the current flow on the heaters. But without this, now I can whack this and get it going. It is possible. I need to whack it with a sharp whack. Hit it with a glass rod. That just doesn't sound good. We'll try a pencil. Yeah, let's try to start with a pencil. I think I missed it. Probably some tests you can perform that would do a better job than this. I don't think I'm giving it enough of a shock with this. It's not heavy enough. I need something that's just a little more oomph. Not too much though. I'll knock it right out of the. What do I think is going to happen? Well, if this starts vibrating, we'll hear it, I think. And the radio would start. There's nothing. No high voltage. Come on, man. pretty rugged resuscitation there. Okay. Now, fact is, I have a couple of these. But I got no idea if they're good. And I have no idea if I can just pop it in there. Can you just pop them in? Would look like it. I would think they'd be made to just pop in. Kind of silly if they weren't. But you know what? This could be like negative ground. I don't know if that would be a problem. But it could be a 6-volter. I could have a 6-volt one here without knowing it. Oh, for use only on approved 6-volt DC. Yeah, okay, not that one. Or this one. Just getting patent numbers here. That's not going to help. It's a K1222, so what are the chances? Chances are this is no good also. I'm going to stop and have a look here. Let's have a little chat with the co-pilot here.
Hey Jim, what's up?
So I'm working on an old radio. It's an old car radio and it has a vibrator in it. Looks like the vibrator doesn't work, but I have another one in my shop, and I'm curious about whether I can try the one I have in the radio. The one I have is called a K1222. Mean anything to you?
The K1222 might be a model number or part identifier, but without more context it's hard to say for sure. If it matches the specifications of your radio's original vibrator, it could be worth trying out. Just double check compatibility with the radio's voltage and pin configuration to avoid damage. Does that help?
Yeah, that's okay. Thanks. Shutting you off. Give me the boot. Well, that wasn't very helpful, was it? I mean, her advice is good, but you didn't really need to hear it. Can't just plug this in and find out what happens. That would be a little bit silly, because that would be silly. So let's pop this out. Oh, check it out. This is not, what has he done here? Was not expecting that. There's no bottom on that. Okay, let's see what's going on here. I have to get this camera operating. Just give me, well, I guess in a video sense, it's a fraction of a second. Okay, let's take a look at this. So he's, did the bottom stay behind? Is that what happened? I think that's what happened. I think the bottom stayed behind. Yeah, that's what's happened here. I thought there was no bottom. But, yeah, you know, I should have probably done exactly this. But just the same, this has an odd look to it. I wonder if it isn't. I gotta switch cameras here. got my arms crossed. I wonder if this is an electronic one. What's over here? Oh, it's gotta go just past the. Well, it looks like a vibrator for sure. See how it's got a rubber all over the place to try to insulate the sound. Well, this is all new to me. Let me get the vibrator right out of there. What am I going to gain by getting this out of here? Very rubbery material. I can't believe it's like that. Wow, okay. So we can see one lead wire here. It looks just fine. It's coming up to this connection. The other lead wire is probably connected to the frame. I don't want to take this band off. Up in here is the reed, the part that vibrates, and the contacts are up in here. You can see them. Yeah, no real benefit to doing this, but why not? Very stiff. Which is probably normal. I have no idea. Is this rubber band interfering with it? What could go wrong? There's nothing wrong with this at all, and something else has gone wrong somewhere else. And I jumped to conclusions. The fact that I saw current flow in the power supply when I hit the switch indicates power was getting to the radio. All the wires look continuous. I didn't get this plugged in properly. It sure felt like it. So the idea is the power from the power supply goes in here through the switch. When you switch it, the power then, the 12 volts, travels into this power supply to trigger the vibrator and set up a situation to create an alternating current that can go through this transformer, come out the other end, and produce high voltage, and the high voltage is sent back on the other wire. One of these is doing one job and the other is doing the other. Well, I can pretty much see, I think. Maybe not. Okay. Just checking things out. Oh, here's another wire right here. It looks like it's been arc welded. And it looks great. You know, coil. I could check the continuity of the coil. I found the other wire, so I'm quite sure of what I'm doing. Let's see if there's continuity. I'm going to do it with an ohm meter. So that pretty well proves the coil is good. How come it didn't vibrate? Since I have the vibrator out, so the radio will make no attempt to produce high voltage with the vibrator out. So I could turn it on and I could look for voltages here. I should look for the 12 volts that should be present somewhere, you know, for one of these pins. It's got kind of a weird long one and two shorter ones. Usually they do that because they're concerned that this make contact first. And that is the one that goes to the frame. This other one goes to here, which is probably one of the contacts. Something like that. And then the something and something. Yeah, so turn the power on, look to see if there's 12 volts somewhere here. That sounds like a good idea, so I'm going to do that. I notice I just have this wire tucked tight. Okay. Switch is off. Voltmeter's ready. And I'm going to have to stop pretty soon. Okay. Looking for 12 volts or so. How are we looking for it? So I can look on the terminals back here. I can come through the holes. I'm going to do the terminals. I'll put the meter here. Do one lead to ground and the other do the terminals. Let's see if one of them's got 12. Okay, I like the plan. Here we go. Watch the current meter. Yep. Showing me 12 volts. How about here? I think that's a big yes. How about here? And how about here? Two places for 12 volts. I'd have to look at the schematic to say much more about how this is supposed to work, exactly how this is supposed to work, and why can't we plug this in just like this without putting it in the canister? And give it a hit. Power off. It's a little hard to shove in there without this canister, so I'm just going to temporarily go like this, and go like that. These things, I know these things are tough. You know, I guess they're not supposed to come out when the car's running. So there we are. Pull this can back out. Leave the gizmo. Can't let it contact there. To block it. Okay, so what we're hoping is this thing will start vibrating. If it does, the radio may come to life. Just fiddling around with it may have tickled its fancy. And what else could go wrong? What could go wrong? No, here we go. It's vibrating. You can see it. See if it is vibrating enough. You don't quite have 12 volts over there. Could be as simple as that. Or it could be it's producing voltage and I don't realize it. I think we'd hear this thing for sure if it was clacking. We would see it. And I don't think it's vibrating right now. Let's put the better camera on it here. Elevate it a little bit. A little clumsy here. Whoops. There we go. So I think what I saw it move once. I'm going to turn the radio off. Yeah, it moved once. It's just not quite enough. I just don't have enough juice coming from my power supply. You know, maybe my wires are too light. My big white return wires. Nothing's warm. So we're going to up the voltage here. Just bear with me while I try to read that voltmeter. Oh, well, we saw what it was. It was 11 something. There's a 13.8 mark on there, so I've set it there. And it sounds like the cooling fan decided to speed up here. Okay, let me get this just set. How much do I bet it's going to work this time? I bet you it's going to work. Okay, so I'm getting ready to turn it on, and here we go. No, I would say that did not vibrate. Well, let's check the voltage that's reaching it, because maybe again, it could be sending a glorious 13 volts at the radio, but it might only be getting 11. Well, it would be getting at least, well, it was getting 11 something, so it should be getting at least 12 now, I would guess. Let's take a look here. It was this one. It's the 14 volts, and this one 14 volts. So I think what would be considered now is a vibrator's tired. He hasn't got it anymore. vibrator testosterone has come to an end. Just can't make it happen. So I think that's really the situation. How this worked at the other guy's shop, well, you know, things work and then they don't. I think that's so. I think a new vibrator, and then we'll be back in business. The thing about this radio, though, is it's full of its old parts, like these capacitors here, one over here. I shouldn't say full. It has these old parts, and there's some these big ones here are quite important. Like I'm getting on camera. Yeah, the ones in the power supply there, they take a beating. There's a very rough power supply. It beats all its parts up, including the vibrator. I better shut this off. And I shut this off. There we go. So that's the end of this video. What will happen next to this radio, I'm not sure. It may never appear again on my bench, or maybe it will. Maybe with another vibrator. We will see. So thanks a lot for watching. Thanks a lot for watching, and I'm gonna get back to. I have another radio. I'm about 9/10 of the way through. I have it back on my bench tomorrow morning to continue with that. See ya. Oh, that's my power supply.